Well, my journey begins really when I'm a graduate student, when I learned from a real master, Arthur Kornberg, my PhD mentor, also a Nobel Laureate, how to take a complicated cellular process apart piece by piece, in this case using biochemistry to dissect the mechanism of chromosome replication. So that really, the method, his approach, his precision, his focus, really imprinted on me. And I wanted to make achievements at that level, but in a different area of research, because I didn't want to compete with him. And the area of nucleic acids was becoming very competitive even back then. And I wanted to have the opportunity to explore a new area and to develop it into something exciting, but from a lower level, beginning a lower level. And so I had my best friend at the time was a postdoctoral fellow in Kornberg's lab, and he had previously worked on biological membranes, and so we had a lot of talks about that, and it seemed like an area that was underdeveloped. And so I had the notion that a membrane, like the cell surface, was a complex macromolecule, but not a covalent macromolecule. It's actually kind of a fluid, a two-dimensional fluid, things floating around. So coordinating how such a complicated fluid structure could be built seemed like a real challenge. And so I was aware of Pilates' work that I mentioned in my lecture, but I decided to work as a postdoc in a laboratory of someone who was doing some really advanced thinking about how membranes were organized. And during that time, I started to think about how one might use a simple microorganism, as I discussed in my lecture, yeast, to understand this process in ways using tools that weren't yet available to study this process in mammalian cells. As I told you in my lecture, cell biologists, that community at the time, was almost entirely working on animals, animal models, mice, rabbits, or cultured human or animal cells in the laboratory, where the tools of the kind of precise genetics that you could use in bacteria or yeast were simply not yet available. I mean, they are now, much more amenable now, but this was almost 50 years ago and it wasn't amenable. But with yeast, there was a growing community of molecular biologists who were using yeast to study essential processes like how cells divide, the logic and the path that cells use before they divide in two, using genetics and eventually molecular cloning. That was not yet possible, but the genetics was there. And of course, there was a 100-year history of using yeast to study biochemical processes that had gone back to the early 20th century. So then I decided that I wanted to work on yeast, and I wanted to use the tools of genetics and eventually molecular biology. And so when I got to Berkeley, my ideas were not yet fully formed. I had a couple of students and we started to explore things. But then I had this student who I mentioned in my lecture, Peter Novick, who joined my lab in my first year. And he embraced the idea of trying to study secretion in yeast. And there were very simple tools, very simple assays that had already been developed. And so we didn't have to reinvent the wheel to begin this, but no one had yet decided to use genetics to study this essential process. So he and I conceived of a way to do this, and within about 6 months, it worked with the first mutant that he isolated, and then I repeated the story. And when he first had the mutant, and we could see biochemically that enzymes that should have been secreted were building up inside the cell, and we found that if you cooled the cells back to room temperature from 37 degrees, the enzymes that had built up could be then released. This had all the hallmarks of a thermally reversible mutation in an essential protein required at some step in secretion. So when George Pilati visited and encouraged us to do the electron microscopy, of course we were going to do this, but we went ahead and did that. And then the rest was, the path became clear. Once that mental image, I'll never forget that image. That moment, I knew that we were on the right path. And then other projects that I'd started in the lab, I just dissolved, and I just focused everything on that because I knew that here was a gold mine. And I'm grateful to Novick and then subsequent generations of equally talented students to realize that dream. But again, I think it goes back to what I learned as a student, even in college, but especially as a graduate student. If you've got an important problem like this, the way to do it is to break it down piece by piece. A really, reductionist approach. That is my method, is taking a reductionist approach to a complicated problem. And the hope is now with this bigger problem that I'm not just working on my lab, but I'm organizing around the world, that a reductionist approach to a disease like Parkinson's will also produce new targets for therapeutic intervention. Well, the advice that I give is seldom listened to. Here's what I tell a student, particularly a good student in my lab, someone who's clearly able of working themselves. The best students in my lab, I realized they have a certain ability to know what to do next. The best students don't need or even want to be told. They know what to do next. And the students who may be technically good but are not creative, they need to be told, or they want to be told. But the best students know what to do next. So if I have someone like that and they have their own insight, what I encourage them to do is to not just continue to do what they've done in my lab. Use your creativity and go off and do something new, do something different. I mean, if you're not going to change at that point in your life, you're never going to change. And the system, and even most people, are very conservative. If someone is a successful postdoc and they publish well, they almost invariably assume that they have to just keep doing the same thing. And I think that's a shame, because you're given an opportunity as an academic scientist to start your own lab. Why do the same thing? I mean, why not take the lessons that you've learned and apply them to something else? Obviously that's what I did, and I have no regret. Although, at first, when my first grant was trashed, and it looked, and people were very skeptical that I would be able to do anything. The other thing that I got as a graduate student that I think was, and now I've appreciated as I've grown older, I developed a sense of self-confidence, not arrogance, but just self-confidence. The work that I did in Kornberg's lab was a real breakthrough also. And I learned from observing others make important discoveries and then being able to do it myself, that you have to have some internal confidence in your ability to make something happen. And this, in experimental science, most things don't work. But when you have the experience of having something work and doing it with your own hands, then that builds confidence. And so if somebody has had that experience, there's no excuse to not do something different. Okay, so I tell this to my people, and very few of them listen. Even Peter Novick, who, as brilliant a student as he was, really unbelievable. When he decided he had his own lab, he called me up and he said, well, you've got this whole pathway. Can I take the second half of the pathway, the genes? And I said, well, of course you can do it. I'm not working on it. But he could have done something completely different, new. But like most people, he was very conservative. This was working. You're not working on it. I want to work on it. Okay, so he did very well. He's a member of the U.S. National Academy of Sciences. But he is not the most successful student from my lab. I've had people who they would never have dreamed of continuing to do the same thing because they had their own, they wanted to build their own world. And so I've had a few others who were just been spectacularly. One who I co-mentored won a Nobel Prize a few years ago. And completely, terrific scientist, very creative, and he, did something brand new. And I have another one who I hope will win a Nobel Prize too. So, but I admit, that takes a lot of confidence. But that's what I tell people, the advice I give. And, they've seldom embraced that advice. But what I also tell them is, whatever you do, focus. Just pick an important problem, even if it's just to continue. Focus, because smart people have so many different ideas. And what you need is filters. You need blinders to see the important question, and then just to laser sharp focus on that problem at hand, and don't be deflected by the daily failures of experiments. Just keep your eye on the big picture. Well, an individual can't solve all problems. A beginning assistant professor should focus on his or her scholarship. Of course, when you come to a university, you have teaching responsibilities. And I faced that too. When I started at Berkeley, I didn't consider myself a public servant, even though I was in a public university. I thought I was there as a scientist to do great science. But then I had to teach. And so this was quite a shocking experience for me, because I was suddenly facing students in the biochemistry class who mostly were intended to go to medical school. And, they didn't have my passion for science. They just wanted it explained so that they could do well on tests. And it took me a while to adjust to that, so I was not terribly sympathetic at first, So, but after a while, I realized, these people are hardworking, smart, honest, ambitious. Just because they don't want to be experimental scientists doesn't mean you shouldn't, try to get them excited about the science. So then I've learned to develop skills as a lecturer that I think became from my experience with students. So I've learned to really value I enjoy teaching. I particularly enjoy teaching undergraduates. It's to me, a very rewarding experience. So, but suddenly when you have a job as a young faculty member, you have all kinds of. I mean, the other thing that is shocking is, as a student and as a postdoc, you've trained or you're training yourself to know how to do your own work, but you don't necessarily supervise the work of other people. But when you become a mentor, then that becomes your job, is supervising other people. A job for which you were never really trained. So that's a real transition, that some people don't succeed because they never adjust to that new reality. And, that any of us succeed in this business is amazing. So you have to call on a skill set that you never had. And it's a challenge. But, if you want to succeed, you have to learn how to work with other people. And they come in all kinds of different personalities. And so you have to learn how to. When I started, I thought, again, from my experience as a graduate, my mentor, Arthur Kornberg, he was a great scientist, but he was he was cruel, verbally cruel. He could be verbally abusive. And if you didn't do it his way, he would let you know. I mean, he could be really rude, either in private or in public. It was just awful. But I thought, well, all you have to be is tough like that, and you just force people to do what you want them to do. But, when I started, and I thought, if I could just be tough like that. But that's not my personality. And so what I learned very quickly is you have to optimize your own personality, not what other people do. You have to do what you're comfortable doing. So my style is I get excited, and if they can't get excited about the ideas that we're exploring, then it's just not going to work. So I look for people who can share my enthusiasm, and many of them need guidance about what to do next. But I'm always looking for the one who knows what to do next. Those are the best. I would discourage them from having that. It's because it's completely unrealistic. Completely unrealistic. My parents wanted me to be a real doctor, and I disappointed them by becoming an experimental scientist. But I can tell you, on the morning of the Nobel Prize announcement, when I called my father, he was beside himself. He had long forgotten that I was supposed to be a doctor, a real doctor. So, but that is not a realistic goal. No one should ever have such illusions. There's so many people who made such important discoveries that for whatever reason they don't win a Nobel. That should not be the goal. The goal should be the thrill of discovery. That's the most satisfying, enduring thing about science. That is the only reward that matters. Yeah. I mean, think about that. I mean, if you're there in the laboratory and you make an observation that shines a light on something that no one has ever seen, that should be just enough. That should be enough. That should be the motivation. Now, of course, as my career advanced and I started getting recognition and awards, then the drumbeat starts, and that people have been nominating you for the Nobel, and so it's hard to put it out of your mind. So the week before I won the prize, I was at a meeting in Germany where I'd won some other prize of the German Biochemical Society, and it was a Friday afternoon for my lecture, and the man who introduced me said, well, so many of the people who've won this prize have gone on to win the Nobel. And he looks at me, he says, well, that decision is coming up on Monday, isn't it? I said, oh, thanks. So then I got home Sunday night, and the next morning, someone was going to get a call, or some people were going to get a call. You just know when it's going to happen. And my wife was ill at that point with Parkinson's, and she had a caregiver with her because she was suffering from dementia. And so I got home and I said, I'm tired, I'm going to bed. But look, you got to see this article. It's online. It was from a reporter from Stockholm who wrote on the Associated Press an article entitled 5 Discoveries That Have Not Yet Won the Nobel. And I was on the list. So I showed it to my wife and I said, this reporter knows nothing. It's just idle chit chat. I'm going to bed. So I went to bed. But of course, that night for years has always been a problem night since I know somebody's going to get a call. So, but I was dead to the world at 1:20 in the morning when the phone rang. And my wife, who I told you was already suffering from dementia, she heard the ring before I did. And she blurted out, "This is it." and of course, my heart started racing. But, normally you get a call in the middle of the night, it's usually bad news, right? But nah, I didn't think it was bad news. So I raced to the phone and I picked it up, and I'm sure my hand was trembling, but I heard this lilting Swedish voice, and congratulations. So first thing I said was, "Oh my God." And then he said, please be sure this is not a hoax. This is real." I said, "I know it's real. I recognize your voice." So, I would be lying if I didn't say I lived for that moment. When people tell you you're being nominated, it's only a matter of time. You can't unforget that. So, okay, so then it happened. But now that I've seen it for over 10 years, it's like a roll of the dice. You just never know. There's so many great people who have done brilliant work and so you just can't count on that. And as you're starting your career, that shouldn't even be on your mind. You should be doing it for the fun and thrill of discovery. That's the only enduring motivation.